Like, then I really did everything for that class.
All right, there you go, folks.
Why is that? Why is the light for that?
Yeah, I don't know.
So this unit, we started with quadrilaterals, which is just a four-sided figure. And then we talked about parallelograms, which is a specific kind of a quadrilateral. And now today we're talking about a specific kind of parallelogram.
The square.
So it's a rectangle. We'll do squares tomorrow. So a rectangle has all the properties of a parallelogram plus two extra ones that make it a rectangle versus just a generic parallelogram. Okay? So the first property that makes it different compared to a regular parallelogram is that the angles in the corner are right angles. So I would take that highlighter you grabbed and highlight those four right angles. Because that's telling us it's a rectangle. Those four right angles automatically make it a rectangle. The other one that automatically makes it a rectangle would be a congruent diagonal. So I would highlight your diagonals. They are the same length, whereas in a parallelogram they weren't necessarily. But they are for sure congruent in a rectangle. So now we're just going to find a bunch of angle measures and side lengths or segment lengths in rectangles, okay? That's what we're doing today. So the first one, let's see here. I don't want a highlighter though. Okay, let's see what we can do. QR. What do you guys think QR is? 10. Opposite sides are equal because it's a parallelogram. What about SR? 24. Same reason, opposite sides are equal. SQ. What do you guys think? Do we know SQ?
14.
14. Could be, but it's not. Right, because what kind of an angle's right here?
Right.
Right, so if I were to draw out that triangle, 24, 10, we're looking for this guy. You guys see how it's the Pythagorean theorem? What side is your hypotenuse?
QS.
QS, or the variable, right? So x squared equals 10 squared plus 24 squared. Now we just crunch it out. This one's nice, we get a whole number. 10 times 10 is 100. 24 squared, I think it's like 576. Someone should correct me. Add them together, 676. Then square root, folks. 26. 26, very good.
14 is pretty close.
You were pretty close.
You want to know how I got 14?
What would PR be?
26,
26, because they're the same. And QT? 13. I would put 13 in all these, you guys, just so you have it on one of your examples, that they're all the same in there. Just a good reminder for yourself that all those links in there are the same. Okay, you guys get a head start on the next one. Same kind of problem, just different numbers, and I'll catch up to you, okay? Fill out the ones you can right away, and then you do have to do Pythagorean theorem. guys see we got the same thing? Close to it. Mostly just check my mental math skills. Were you okay? Are we all right with that one? Yeah? Okay. Thank you for the non-verbal responses. That's
Yeah,
good.
I'm all right with
No,
it.
there's a lot of nods, but thank you for those that did, so I know. All right, angles. Let's not worry about the bottom right now. We're going to fill in all of the missing angles because it will make your life easier. Okay, so remember, it is a parallelogram, right? So we still have parallel lines, so like alternate interior angles, still a thing. So if I have 27 here, where else would you assume 27 would be?
Bottom left.
This guy?
Bottom right.
Right here, right?
Yeah.
Those are the alternate interior. Write it down. Now remember, all these little segments in here of your diagonals are the same. So what kind of a triangle is this guy on the bottom? M and L. You're to classify it.
Right.
No. Isosceles. And what do you know about an isosceles triangle?
They're all equal.
The
Base
angles.
angles are the same. So if this guy's 27, oh, this guy's 27. And then alternate interior angles tell me this guy's 27.
Then
That's exciting.
the other ones have to be 63, right?
Right, because they add to 90.
Right.
Are you okay with 63?
63. Well, that's okay, KP.
Now look, 63 is filling all the other spaces
What?
around the corner.
What is it? I'm just cooking.
Let's say we wanted to find this middle guy right here. How are we going to find this guy?
Triangles out of
Yeah.
Do something.
Subtract from 180 because we got a triangle. Tell me what you get.
90.
Nope.
Ah!
54.
Should be 54.
Yeah, it should be 54, guys.
And then vertical angles. Tell me that guy's 54. And it'll in your pair, right? Subtract from 180.
It's like 126.
Is it 126? Yeah.
Bam!
Landon's on fire. All right, now you guys can fill in the bottom. But at least on this example, you have all the angles written down in your notes just so you have it for later on. No decimals. And JK. And JK would be 90. That's the big corner
Put it up right
angle.
now.
JL.
We got one.
And L.
Yeah.
And JL. KML. Will you guys check to see if I picked the right ones out?
Hold
Just for our video lesson friends that they're good. Are we okay?
I don't know about that.
We don't match?
No, I'm just trying to figure out what. You're fine.
I'm good?
Yeah.
All right. Do you guys want to get a head start on this one? Okay, this one's a little different. See if you can figure it out. At least find the three ones in the middle.
What was that? The last one.
Are we okay with these, at least those ones?
Yeah.
Okay, so now if we're getting kind of stuck, don't forget this is isosceles, right? So
It's
what's left
equal.
over from 180 if I take 64 away?
The B is
116, right? Now we gotta split that equally between this guy and this guy.
58.
Yeah.
Bam.
So here's a 58. There's a 58, and then up on top, too short, and then
And it's 32 for the other ones.
how'd you get 32?
I'm cooking.
Equal 90.
90. You guys get those?
What?
Alright, fill it in. XWY. YXZ.
I'm already done.
Why do you divide this by 2? You divide this by 2.
CXY. Will someone please check that for me if we match? So much. All right, when you're ready, flip it over. And we'll do a little bit of algebra. A little bit of algebra.
Yeah, a little bit of algebra.
Yes, line.
Little bit of algebra, your favorite. All right, we have a rectangle. Let's set up an equation here. All right, let's mark these angles in our notes. KJL is this guy right here. And angle JLK. Ooh, this is a good one. What do you guys know about the red and green angle?
Equal 180.
They're not equal.
They're not equal. They do equal 90. Right, this is alternate interior to this guy here. And what do you know about this corner angle? Equals 90.
Yep.
You guys knew it. Good job. So 2x plus 4 plus
Oh, it's not.
7x plus 5 equals 90.
It's not.
There should be a whole number unless we did it wrong earlier. Yeah. I get 9. All right, the next one, I think we get parts of our diagonals here. We're given JP and MK. What's the relationship of the purple and blue segment, or purple and green segment?
2 JPs equal MK.
2 JPs equal to MK?
Yeah.
I agree. Well, how do we do that mathematically? How do I make something 2?
Times by 2.
Just multiply by 2.
Yeah, double it.
No, it doesn't. Y equals 11.
Y equals 11. Oh, I did something
Oh,
wrong.
you
I did it wrong.
You said.
I was like, I'm not getting it.
Yeah, no, you said 9. It's
I said 9 for this one.
No, it's 11.
Yes, 11 for this, 9 for that one.
No, you said 9.
Anyone else get 11?
Yeah.
Woo!
I got it first, okay?
Put your hand down.
You guys are good. All right, last one in the coordinate plane. How are we going to show that a quadrilateral is a rectangle using the distance formula? Say it louder.
Diagonals would be equal.
You just have to do it twice because diagonals being congruent proves that it's a rectangle. So will you guys, what are our 2 diagonals here? PR. This half the room, please do PR. This half the room do QS.
Alright, let's go, guys.
And we'll compare.
Is it x2 minus x1?
What's that?
Formula.
QS, the formula, big square root, x squared minus x1,
Hunter, you know you're mobile.
y2 minus y1.
You're mobile.
X1 plus.
Did you get 64?
Yeah, crunch it out, we'll
You did the other one
compare.
You know what that is? Hunter mobile.
No,
Oh, it's distance. Oh, oopsies.
Yeah, you know what that is?
Little distance formula.
I was already like this far.
Do shisa. Mobile.
That's what I got, but I don't know actually. I don't know. Maybe I did it wrong.
No, I'm not saying you did.
I probably did.
I agree.
I mean, you were the mastermind that came up with the plan.
What'd you
You're
get?
probably right. You're probably right.
Oh, I'm not done yet.
I do those.
You're supposed to get second.
Yeah,
you are.
Not for distance formula.
Oh.
Midpoint.
Alright,
I might have done it wrong. Oh, I looked at Q instead of R. So I did one minus. I didn't look at R. I did everything wrong.
Check on your shoulder, buddy. See if they got the same thing.
Jason, you do it? I don't even know if you do it.
Are we doing PQ or?
We're doing
I already know what I'm just.
I did PR, but I got it wrong.
What is that?
All right, PR. What you guys get?
8.1.
8.1 QS. 8.1. So what do we know?
That means they're equal. They're parallel. That means
It is a what?
parallelogram.
Rectangle.
Yeah.
Okay, before we're done with notes, will you add this like on the bottom of this? So write that down, and then we're gonna add. Let's say we needed to figure this out using the slope formula. What would you have to show would be true?
The sides have to be congruent.
What's the other thing that makes something a rectangle? Congruent diagonals or
90-degree angles.
90-degree angles. So using slope, how do you show something's perpendicular? Opposite reciprocal slopes. Maybe should we write that right under here? I think we should. Using slope, find opposite reciprocals. And maybe you'd have to draw a picture out to make that make sense in your brain. PQRS. So you'd have to find the slope of all your sides. Let's say that was 1/2 and this was 1/2. This would have to be like -2 and -2. That's just an example. But you have to find the slope of all four. And they'd have to be opposite reciprocals, okay?